Hello, good morning everyone. Today class is electrodynamics. In previous class we are discussed Maxwell equation and the integral form of Maxwell equation. Today we have to discuss about the potential function. From Maxwell equations, del dot B equal to 0. Divergence of a vector is 0. Thus, B can be expressed as the curl of a vector. So, we have to write B equal to del cross A, where A is a magnetic vector potential. Also, we have del cross E is equal to minus dou B by dou T. So, substitute B in this equation. So, this equation become del cross E is equal to minus dou by dou T of del cross A. Interchange the del operator and the partial derivative with respect to t. The equation become del cross E is equal to minus del cross dou A by dou T. The RHS is moved to LHS. The equation become del cross E plus del cross dou A by dou T equal to 0. Equation can be rewrite del cross E plus dou A by dou T equal to 0. We have curl of gradient of a function is 0. In this equation, E plus dou A by dou T is the curl of gradient. So, E plus dou A by dou T is equal to the gradient of an unknown scalar. Here we take the unknown scalar is scalar electrical potential V. So, E plus dou A by dou T equal to minus del V. So, from this E equal to minus del V minus dou A by dou T, where V is equal to 1 by 4 pi epsilon 0 volume integral rho by r dv dash, and the magnetic vector potential A equal to mu 0 by 4 pi volume integral J by r dv dash. The electric field in E is equal to minus del V minus dou A by dou T has two parts. The first part minus del V is due to charge distribution rho, and the second part minus dou A by dou T is due to the time varying current J. In static case, dou A by dou T equal to 0. Therefore, E is equal to minus del V. We have del cross H is equal to J plus dou D by dou T, where H is equal to B by mu and D equal to epsilon E. The equation become del cross B by mu is equal to J plus dou by dou T epsilon E. Mu is mu to RHS. The equation become del cross B is equal to mu J plus epsilon mu dou E by dou T. Substitute B in this equation. The equation become del cross A is equal to mu J plus epsilon mu dou E by dou T. We have del cross A is equal to del into del dot A minus del square A. It's a vector triple product del cross A. So, apply back cab rule. So, equation become del into del dot A minus del square A is equal to mu J plus epsilon mu dou E by dou T. Substitute E in this equation. The equation become mu J plus mu epsilon dou by dou T minus del V minus dou A by dou T is equal to mu J minus del mu epsilon dou V by dou T minus mu epsilon dou square A by dou T square. Rearrange this equation. The equation become del square A minus mu epsilon dou square A by dou T square is equal to del into del dot A plus mu epsilon dou V by dou T minus mu J, where del dot A plus mu epsilon dou V by dou T equal to 0 by Lorentz gauge condition. So the equation become del square A minus mu epsilon dou square A by dou T square is equal to minus mu J. This is the non-homogeneous wave equation for the vector potential A. It is also called wave equation because its solution represents waves traveling with a velocity equal to 1 by root mu epsilon. For static field, Lorentz gauge reduced to del dot A equal to 0, which is called a Coulomb gauge. Similarly, del dot D equal to rho. Substitute D is equal to epsilon E. The equation becomes del dot epsilon E equal to rho. Move epsilon on RHS. The equation becomes del dot E equal to rho by epsilon. Substitute E in this equation. The equation becomes del dot minus del V minus dou A by dou T equal to rho by epsilon. This implies del square V plus dou by dou T del dot A is equal to minus rho by epsilon. From Lorentz gauge, del dot A equal to minus mu epsilon dou V by dou T. Substitute del dot A in above equation. The equation becomes del square V plus dou by dou T minus mu epsilon dou V by dou T is equal to minus rho epsilon. The equation becomes del square V minus mu epsilon dou square V by dou T square is equal to minus rho epsilon. This is the non-homogeneous wave equation for scalar potential. So, here we get non-homogeneous wave equation for vector potential A and non-homogeneous wave equation for scalar potential. The non-homogeneous wave equation for vector potential A is del square A minus mu epsilon dou square A by dou T square is equal to minus mu J. And non-homogeneous wave equation for scalar potential V is del square V minus mu epsilon dou square V by dou T square is equal to minus rho epsilon. So, let us wind up the class. Thank you.